Good day, everyone. Welcome to our Statistics and Probability class. Today, we are going to discuss one of the lessons in the mean and variance of the discrete random variables. Lesson 1, Interpreting the mean and variance of a probability distribution. In this lesson, we will going to interpret the mean and variance of discrete random variable and recall and apply the formulas for the mean, variance, and the standard deviation of a discrete random variable. Let us recall what you have studied in your junior high school about the formula of the mean and variance. Formula number 1. U of r mean of x equals u of x is equal to the summation of x of I times the p of x. Formula number 2. Variance is equal to the summation of x squared times the p of x minus the mean squared. Formula number 3. Variance is equal to summation of x minus mu squared times p of x. And formula number 4. Standard deviation is equal to the square root of variance, which is equal to the square root of x squared times p of x minus the mean squared. Activity number 1. What's the formula? Situation. I am thinking of finding the average number of heads that would appear if I will toss two coins together twice. Which formula should I use? Very good. The answer is mean is equal to summation of x of I times p of x. I have here set of pictures. Can you guess what is common in the set of pictures? Excellent. Probability or games of chance. Did you win already in any games of chance? If you were given a chance, will you join in this kind of game? Let's have probability problem. Okay, let's have an example. Let's try this. Suppose an unfair die is rolled and let x be the random variable representing the number of dots that would appear with a probability distribution below. We have 1, probability is 0.1, 2, probability is 0.1 also, 3, the probability is 0.1, 4 is the probability is 0.5, 5, the probability is 0.1, 6, the probability is 0.1. The first question is, what will be the average of dots that would appear? To get the average, we are going to use the formula. Recall, we have the formula of summation of x sub I times the p of x. Okay, we're going to multiply this x and p of x. So we get 1 times 0.1, 0.1. 2 times 0.1, 0.2. 3 times 0.1 is 0.3. 4 times 0.5 is 2. 5 times 0.1 is 0.5. 6 times 0.1 is 0.6. Okay, we're going to get the total. 0.1 plus 0.2 is 0.3 plus 0.3 is 0.6 plus 2 is 2.6 plus 0.5 is 3.1 plus 0.6 is 3.7. Okay, so therefore the average of the dots that would appear is 3.7, and 3.7 is near to 4. Second question is, how does the assumed value of the outcomes vary from the average of the dots that would appear? To get the answer, we're going to use the formula of variance, which is equal to summation of x sub I x squared, division of x squared times p of x minus the mean squared. And to get this to get the answer, we are going to pick up or complete this table. Okay, we are going to get the x squared. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9.
4 times 4 is 16. And 5 times 5 is 25. 6 times 6 is 36. And then we're going to multiply this x squared to the probability of x. So we have the first 1 times 0.1 is 0.1. 4 times 0.1 is 0.4. 9 times 0.1 is 0.9. 16 times 0.5 is 8. 0.1 times 25 is 2.5. And 36 times 0.1 is 3.6. Okay, we are going to get for the sum. Summation of x squared px is equal to 0.1 plus 0.4 plus 0.9 plus 8 plus 2.5 plus 3.6 is equal to 15.5. Okay, we're going to substitute the values that we get. So 15.5 minus the mean squared minus the mean squared. So that is 3.7 squared. So 15.5 minus 3.7 times 3.7, that is 13.69. And 15.5 minus 13.69, that is 1.81. So to get for the standard deviation, we're going to get the square root of our variance, which is 1.81. And the square root of 1.81 is 1.35. Small variance or standard deviation means that the assumed values of the data points tend to be very close to the mean. And the variance or standard deviation measures or describes how far a set of data is spread out.
The first data in the following examples is somewhat expected to have a higher variance in standard deviation or variability compared to the other data. Example number 1. The population size of 100 different countries around the world compared to the population of 10 countries belong to the first world countries. Example number 2. The number of students in different universities compares to the number of students in a class in a particular school. Example number 3. The number of people who love to play basketball in different barangays to the number of basketball players in different teams who play in the first quarter game. Let us have a short assessment ourselves. Analyze the following pairs of data and identify which of the following will most likely yield to a higher variance and higher standard deviation. Number 1. Number of students from different grade levels, or number of boys in a family with 3 children. You have 5 seconds to answer. Number 2 question. Number of fish inside the aquarium from different households, or number of fish inside a can from different local brands of sardines. 5 seconds again to answer. Number 3 question. Number of COVID-19 patients from different hospitals, or number of family members with fever in a barangay. Again, you have 5 seconds to answer. Number 4 question. Number of M&M's peanuts inside a 1.69 ounce of bag from different retail stores, or number of kernels in corn of different sizes. Number 5 question. Number of players in a group playing the game The Boat is Sinking. or number of passengers in different luxury cruise ships? Let's check your answers. If your answer for number 1 is the number of students from different grade levels, that is correct. Number 2, if your answer is the number of fish inside the aquarium from different households, your answer is correct. If your answer for number 3 is the number of COVID-19 patients from different hospitals, your answer is correct. And number 4, if your answer is the number of kernels in corn of different sizes, your answer is correct. And for number 5, if your answer is the number of players in a group playing the game The Boat is Sinking, your answer is correct. Remember, you were born a winner, a warrior, one who defied the odds by surviving the most gruesome battle of them all, the race to the egg. You are an achiever.
Thank you and good day. See you on my next video. Learning math is easy, but it takes time. I'm teacher Cleta D. Hernandez. May God bless you all.